Hello everyone. So this is a question from JEE Advanced 2026 paper 2. Xa plus and Yb plus are hydrogen-like species. Wavelength of light absorbed during the transition between n equal to 1 and n equal to 2 of Xa plus is lambda. Okay. Wavelength of light absorbed during the transition between n equal to 2 and n equal to 4 of Yb plus is 9 lambda. The lowest possible value of A plus B. Okay. So the chapters involved is structure of atom. So H-like species, since they have mentioned, are species like He plus, Li plus 2, etc., which contains one electron. So the criteria is they should contain one electron, H-like species. And for them, the expression of energy is En is equal to minus 13.6 into Z square by N square, where Z is the atomic number and N is the principal quantum number, and the unit is electron volt per atom. Let's say this is equation 1. Okay. Given that Xa plus and Yb plus are, H-like species. Okay. If we look at such H-like species carefully, for example, He plus, whose atomic number is 2, Li plus 2, whose atomic number is 3, beryllium plus 3, whose atomic number is 4. The atomic number of them, that is 2, 3, and 4, is one more than the charge they contain. That is, for them, I can write Z is equal to charge plus 1. Okay. So you can see in the case of He plus, atomic number is equal to 2 and the charge it contains is 1. So therefore 2 is equal to 1 plus 1, which is correct. Similarly for lithium plus 2, atomic number is 3, charge is 2, so 2 plus 1, which is equal to 3. Similarly for beryllium plus 3, atomic number is 4, charge is 3 plus 1, which is equal to 4, right? So therefore, based on this, I can write Z of, or the atomic number of Xa plus will be equal to the charge it contains, that is A plus 1. Similarly, I can write the atomic number of Yb plus will be equal to the charge it contains, that is B plus 1. Okay. One more thing we should know is that energy of shells increases as we move outwards. Okay. Therefore, their order, the energy order is going to be second more than first, third more than second, fourth more than third, and so on. Okay. So let's talk about Xa plus. So in Xa plus, light of wavelength lambda is absorbed and electron jumps from n equal to 1 to n equal to 2. Okay. So if we draw a diagram, this is the nucleus, this is n equal to 1, and this is n equal to 2. So let's say our electron is here. So a light of wavelength lambda falls on it and it gains energy and jumps to n is equal to 2. Okay. So the energy gained by electron is equal to hc by lambda. We know this according to Planck's quantum theory, right? So therefore, the energy gained by the electron will be E2 minus E1, because we know that E2 is greater than E1. So which will be equal to hc by lambda. Okay, and we know the equation that En is equal to minus 13.6 Z square by N square, and since it is Xa plus, the atomic number of Xa plus is Z is A plus 1. Okay, so taking care of these things, I can write E2 as minus 13.6 A plus 1 whole square divided by 4 minus of 13.6 A plus 1 whole square divided by 1 will be equal to hc by lambda. Okay, so when we do this calculation, we will get 3 into 13.6 into A plus 1 whole square divided by 4 is equal to hc by lambda. Okay, let's talk about what's happening in YB plus. In YB plus, light of wavelength 9 lambda is absorbed and electron jumps from n equal to 2 to n equal to 4. That is, with respect to diagram, I can show it to you. This is the nucleus. This is n is equal to 2. This is n is equal to 4. And let's say the electron is here, and a light of wavelength 9 lambda falls on it. It absorbs the energy and it jumps to n is equal to 4. Okay, so therefore energy gained by electron will be equal to hc by the wavelength 9 lambda. Okay, and energy gained by the electron will be E4 minus E2, because we know that E4 is greater than E2, so which will be equal to hc by 9 lambda. Okay, from equation 1, that is, En is equal to minus 13.6 z square by n square. One more thing is the atomic number of YB plus is equal to B plus 1. So therefore, I can write E4 as minus 13.6 into B plus 1 whole square divided by 16 minus of 13.6 into B plus 1 whole square divided by 4, that is E2, which will be equal to hc by 9 lambda. Okay, so when I solve this, I get 3 into 13.6 into B plus 1 whole square divided by 16 is equal to hc by 9 lambda. Okay, so I will move this 9 to LHS. So I will get 9 into 3 into 13.6 into B plus 1 whole square divided by 16 is equal to hc by lambda, and we have found the value of hc by lambda already, that is this. So I can substitute the value of hc by lambda, that is this value, here. So therefore this whole thing will be equal to 3 into 13.6 into a plus 1 whole square divided by 4. Okay, so this 3 gets cancelled, 13.6 gets cancelled, 4 is a 16. Okay, so ultimately I get 9 by 4 is equal to a plus 1 divided by b plus 1 whole square, right? So therefore I can write a plus 1 divided by b plus 1 will be equal to plus or minus of 3 by 2. So there are two cases now. In first case, a plus 1 by b plus 1 is equal to plus 3 by 2. In the second case, a plus 1 by b plus 1 is equal to minus 3 by 2. Okay, so this is not possible because either a or b has to be negative for this whole thing to be true, and it is not possible that a and b is negative. Okay, because it is the charge. And since we want, so this case is possible. Okay, since we want the lowest possible value for a plus b, so the lowest possible values of a and b that will satisfy this equation is a equal to 2 and b is equal to 1. Okay, so therefore a plus b is going to be 3. So the lowest possible value of a plus b is 3. So our final answer is 3. Okay,